Hello, my name's Charles Davidson. I live in Hercules, about 1.5 or 2 miles from Selby Slag that you're watching here. It's 66 acres of slag material that was pushed into San Pablo Bay in the north part of San Francisco Bay. Uh, Underneath that asphalt covering, there's 2.5 million tons of slag that was formed from a smelter that was on the site for 100 years, from 1872 to 1971. They were smelting lead, copper, gold, and silver. And the slag was pushed in by bulldozer while it was hot into the bay. So much of the slag is actually fused. And so what they want to do is put a seawall in front of this because it's open to San Francisco Bay. And if you look at the far part of the slag, you can see the hills open up, and that was formerly a creek that was going directly into the bay that was covered with the slag. And right now it's still pushing through the slag, so it's also pushing the toxic metals into the bay, which are nickel, cadmium, arsenic, antimony, and nickel, and various other different kind of toxic substances. And so what we want to do is redo the Department of Toxic and Substances Controls project. That's for the State Department of DTSC. And so if we could take a look at some of the slides, I'll show you specifically what the DTSC is planning on doing and what we would like to do differently. So when the slides come up, I will show you.
Give me one sec. All right.
Okie doke.
Here we go. Okay. And there you go, Charlie.
All right. So we've been working for the past 3 years with DTSC because we have serious concerns about their project. They plan on doing significant amounts of dredging in the area and also pile driving for the sheet metal seawall that they plan on putting along the face of the slag for nearly 1 mile. Next slide, please. So there you can see in the yellow in the picture is actually where there's submerged slag. That's about 5% of the slag. And they want to dig that up pretty much throughout the entire length of the slag and put it underneath the asphalt after they remove asphalt and put more asphalt on. And we're very, very concerned about that because there's going to be a lot of mud being put up into the bay in various plumes. And that mud, we believe, will contain significant amounts of these heavy metals that have been embedded into the bay mud right there. And one of the biggest problems with that also is that there is the once-through cooling system intake at the Phillips 66 refinery that is just off-site of Selby Slag. Part of the slag is actually owned by Phillips 66 refinery. And also, once they remove that yellow submerged slag, they plan on putting the sheet metal seawall along there. It'll be covered with a bentonite, which is a cement-like substance. However, that is so weak of a material with salt water on one side and with acid on the other side, because large amounts of acid was manufactured at the site to help refine the various different kind of metals. So that is being pushed out by the groundwater. And so the mixture of groundwater with acid and salt water and iron in the steel is toxic corrosion. Next slide, please. And so you can see that the railroad tracks on the upland side, that area, they were going to put a French drain, which is a drain that goes down into the ground with piping in it and filled up with gravel and all. And that would supposedly drain out the groundwater coming in from the creek. They've kind of modified that recently, very recently, and put in that oval area at the bottom, they've planned on putting various different kind of wells with pumps in it. And we don't think that's quite adequate enough for the Cañada del Ciervo Creek. Next slide, please. And here you can see the opening of the face of the slag right into the bay. That dark stuff is really crumbled asphalt. And otherwise it leaks out from the groundwater, and also there's some intrusion by the tidal water going into the bay. And you can also see that the train in the background, and how risky this area is for eventual sea level rise. Next slide. And these are areas that are going to be inundated. And if you take a look at the marine terminal, the base of it, there's a little box there, and that is an intake for the once-through cooling system for the refinery for 40,000 gallons per minute. And we're worried that the dredging and pile driving will bring a lot of plume mud into that, and it's spit out about a half a mile south, where you can see at the bottom part of the picture, once it goes through the refinery. So we feel that various kind of heavy metals going through the refinery mechanisms and piping, and then being spit out into the bay is a really, really bad idea. So we don't like that. And so we've opposed the dredging, and we have remade the project that you can see in the next slide. So the first thing we've done is, you can see at the blue in the bottom, that is a French drain that goes from bedrock to bedrock. It's sitting in a 200-foot end of the canyon right there. The hills go right up. So we're putting the French drain 35 feet down into the ground, and then piping it out into that green oval, which is a wetland, and then it'll just naturally drain out into the bay. The green circles are a living shoreline, which is a breakwater, oyster reefs, eelgrass restoration, and also will function as a breakwater. In the other area, going a little bit to the right there, we're actually going to have covering up some of the lip of slag that is submerged. We're going to have a cement or other impermeable non-reactive material there. And then we're going to have a variegated surface habitat that the living seawall can go onto. So that'll function as a breakwater, as well as a living habitat that will help restore some of the area. And the living seawall is also going to be going around the Rodeo sanitary district that is right on the other side of the Phillips 66 refinery, because they are concerned about sea level rise also. Next slide. So that's pretty much what you have. If you go a little bit, another slide, maybe it'll show the Cañada del Ciervo. Yeah, there you go. You can see how that's going 4 miles back. The hills are 800 feet deep. It goes right under the tanks there. They put the tanks over the creek. It's 60 feet of unconsolidated alluvial sediments. And so, and there's 200-foot hills on either side of the, directly up from those tanks. And so we're putting from bedrock to bedrock the French drain to just cover the exit of the drain and pump it out into that marsh area. And so next slide. Next. Yeah, so we basically, you can see what we've done. We've taken out the yellow, the French drain that they were going to do there. We've taken out those 5 drains right next to it, and we're putting the French drain 35 feet down, draining it into the bay, and using a living seawall with impermeable membrane underneath it for the bay face of the slag. Next slide, please. And the next slide. There you go. And so you'll see some of the area here where we might have some, create a brackish marsh for wave attenuation, and, proper behavior that would be appropriate for a tidal marsh in that area. The question about removing the slag was an impossibility to remove 2.5 million tons of slag with current technology. And I don't think I'd want the DTSC to be trying to do that, and they didn't think that they could do that anyways, and the cost came up to several $billions. There we go. Thank you very much. There's names of our local community people, I think are in the next slide. Yes, and these are local community people who were involved in not wanting the dredging to go on in our area and wanted something better. Maureen Brennan she's on the Sanitary District Board of Directors, and she's the one who brought Hack the Bay and Heidi and all the different people in here to help us with our completing our plan. And we're also planning on involving some business people and other government agencies in making our project a complete project with all the different aspects. Thank you very much.